So today in class, we learned about similar figures. Similar figures are the same shape, but they are not necessarily the same size. The word corresponding, when you look at number 2 and 3, the word corresponding there means that they're in the same position. So similar figures have corresponding angles in the same position, and they must be congruent. They must be the same size or equal to each other. Number 3 tells us that corresponding sides must be proportional. So the same position sides must be proportional. We're going to spend most of this third quarter looking at different geometric ideas. In the beginning, we're looking at proportional relationships still, like we did at the end of the last 9 weeks, and similar figures are proportional. We're going to take figure A and we're going to make a similar figure to it by using a number. We're going to increase the sides by a number. The first thing I would do is I would count the length of sides around A. So A is a square. All of the sides around A are the length 4. So if you look at step A, it asks you to outline figure A with orange. For B, we're going to take figure A and we're going to increase it by 3 times to make a shape that is 3 times as large as the original figure. So if you think about 3 times 4 is 12, we're going to have a square with the side lengths of 12. So I'm counting over 12. And I'm going to count up and down 12. So finish the square. Label this square B and label the side lengths all the way around 12. The next shape we're going to make is we're going to change the shape A by 2 and we're going to make shape C. So 2 times 4 is 8. I'm going to start at the very bottom and I'm going to count up 8 so that my shapes don't overlap. And I'm going to count across 8. And then finish the shape. Label this one C and make a note that all of the sides are 8. D asks us if we can make a shape that is half as large as the original figure. So half means that we're dividing it by 2. So if you think about the original figure, it was 4. So we're going to divide 4 by 2. And we're going to have a shape that is 2 on each side. Okay, so let's label this one D. And make a note that all the sides are 2. The last one asks us if we could make an even smaller shape. And in class we talked about, well, the first shape was 4 all the way around. So yeah, we could make a smaller shape. We could do 4 divided by 4 and have a small 1 by 1 shape. We're going to label that E. So on our paper, we want to come up here to the top and we want to make a note that, yes, we can make a shape that is smaller than D. And we made it 1/4 the size of A because we divided by 4. Now, you have several papers. There were 4 papers in today's lesson. So go to the last page. And we're going to look at this column here. Let me pull my paper so we can see everything. You're going to look at this column where we're comparing different figures to prove that they are similar. So we're going to use ratios to compare the left side of figures in part 1. Okay, so remember we had A and its side lengths were 4. We made B and its side lengths were 12. So we're writing this ratio as the side length, the left length of B over the left length of A. So 12 divided by 4 is 3. C, remember, was this green one, and it had a left side length of 8, and A's side length is 4, so 8 divided by 4 is 2. D is this small yellow one. Its side lengths were 2, and A's were 4. So if we simplify 2 over 4, we have 1/2. E was this very last one we made, and we made it 1 on each side. So 1 over 4 is already simplified to 1/4. These numbers should look familiar. These are the numbers that we use to increase shape A to make shape B. And so what we're proving is that we have similar figures because all the time the left side of each shape was that number that we multiplied by when we simplified that fraction. Now we're going to look at the second page. So what we just found when we figured out these ratios and we simplified them is we found the scale factor. So the scale factor shows you the ratio of corresponding side lengths in 2 similar geometric shapes. So it's how we changed each shape to make the next shape. I've given you a different figure. Figure F kind of looks like a uppercase L. Trace around it with pink. If you don't have these same colors, it's okay. I just don't want everything on the paper to be all the same gray color like pencil, and then it would be gray like the lines on the graph paper. We're going to think about how long each side is as we move around. So the left side of F is 3 units. I didn't tell you this earlier, but the reason we're using graph paper is because we can measure with the units, and you're not having to measure the side lengths with a ruler. That would get pretty complicated. We're also using graph paper because we know that these horizontal lines and vertical lines, where they intersect, make right angles. So when we connect and make these angles in our shapes, we know that those are right angles. So we know that they're the same in all the shapes that we make. The bottom length is 2. The right side is kind of broken up. So the right side moving around, we have 1. Then it kind of goes back to the left 1. It goes up here 2. And then at the very top, the length is 1. So we're going to have to think about all these different lengths as we move around the shape. I don't have a purple, so I'm going to write with this kind of darker blue and hope it kind of looks purple. We're going to make a really big shape for G. We're going to use a scale factor of 6. So when you think about this length, 3 times 6 is 18. So we're going to need to stay close to figure F, and we're going to make a long line that's 18 units long. That's 12. Okay, that's 18 units. It's long. The bottom is 2, so we're going to say 2 times 6 is 12. So we're going to go across on the bottom 12. On the right side, we have to be careful. We have to think about how these little broken up parts work. So this one goes up 1. So we're going to go up here. 1 times 6 is 6. When we move back to the left, in the original shape, it goes 1 unit. So we're going to move 6 units back to the left. It had another up part that was 2. So 2 times 6 is 12. So we're going to move 12 units up. And then the final part at the top was 1. So we're going across. 1 times 6 is 6. And we're going to label this figure G. And then go back around and make a note of how long each side length is. Okay, so this side length is 18. The bottom was 12, 6, and 6, and 12, and then 6 again at the top. For shape H, we're going to use F, and we're going to increase it with a scale factor of 3. We have enough room right here to do that. So we're going to start again with this left side. So 3 times 3 is 9. The bottom is 2 in the original shape. So the new shape is going to be 2 times 3. So it's going to be 6 on the bottom. This right side, that first part that goes up was 1, so 1 times 3 is 3. And then it goes in 3 to the left. This part was 2, so we're moving up. 2 times 3 is 6. And then the top is 1, so 1 times 3 is 3. So we're keeping the same shape. We're keeping all of those angles right angles. We're just increasing the side length by the numbers that were given. So let's make a note. This side was 9. This side was 6. 3, 3, 6, and 3. We want to make shape I 1/2 the size of shape F. So we have to think about that. We're going to divide each number by 2. So if we look at this side, it's 3. So if I divide 3 by 2, it's 1 1/2. So we're going to go down 1 unit and then half of the next unit. The bottom was 2, so if we say 2 divided by 2, that's 1. So we're going to go across 1. This part was 1, so if we do 1 divided by 2, that's half. So we're going up half of a unit. This part was 1, so 1 divided by 2 is half of a unit. 2 divided by 2 is 1, so we're moving up a whole unit. And then at the very top, we had again 1 divided by 2, and that was a half. So we have a real tiny little L shape. We're going to label it I, and then we're going to make a note of the side lengths. So this was 1.5, the bottom was 1, that right part going up was 0.5, the part going in to the left was 0.5, then at the moving up again was 1, and at the very top was 0.5. Let's go back to this paper so we can finish that first column. Okay, so remember we had F, we're still using the left side, so F's left side was 3, and this first ratio we're going to compare it to G. So G was this really big one. The left side of G is 18, and the left side of F is 3. So if we simplify 18 over 3, we get 6. Remember, that was our scale factor. H was the second one we did, and its left side was 9. And the right side of, the left side of F is 3, so 9 over 3 is 3. That was our scale factor. Then we did I, which was this little tiny one, and its left side is 1.5, and F is 3. So to simplify this, we have to kind of give it some thought. When we simplify, that means we're dividing both the numerator and the denominator by the same number. And it's something that can go into both evenly. So if I divide by 1.5, 1.5 divided by 1.5 is 1. 3 divided by 1.5 is 2. And that gives us our scale factor. Now, that's what we did in class. For homework, there was one more page, and it has this L shape. Okay, so copy those notes at the top. We're proving these two statements. Similar figures have the same shape, but are not necessarily the same size. We've seen that. We've made several different squares. They were similar, just different sizes. We've proven that they're the same because their side lengths were proportional. The second statement says the scale factor represents the ratio of two corresponding lengths in similar geometric shapes. And that's what we found when we simplified the ratios. So you're going to do this for homework. This will be a homework check tomorrow. So you're going to think about how long each side is in this U shape. So this left side is 4. The bottom is 1, 2, 3, 4, 5, 6. This side is 4. The top part here is 2, and then it goes down 3. This very low bottom part is 2. It comes back up here 3, and another top part, which is 2. So you're going to use these scale factors, and then I've asked you to make up your own scale factor. So maybe you want to use 4, maybe you want to multiply by 1 and just prove that you could have the same shape, but do that for homework. On the back of this paper, you're going to fill in this right column. Instead, like in this column, every time we counted the left side length, for this that you're doing tonight, you're going to count the bottom side length. So please do that and come prepared to class tomorrow to check it, and have a good afternoon.